5/12 can be written as 8/3, and 1/8 can be written as 8 to the negative 1. And then we have a power of a power, you multiply the power. So this is 8 to the power of 15x minus 3. This is 8 to the power of positive 4 and positive x, so x plus 4. And once the bases are the same, we can just solve the equations by setting the powers equal to each other. So 14x equals 7, x is 1/2. Okay, we good? Okay. (13 and 14) questions about that? We can take log base 7 on both sides of the equal sign. Solve for the exponential first, so you're subtracting 9, then you divide by 3, so it's e to the 4x's alone. E to the 4x is 2, right? So 17. The length, L, is in meters of a scalloped hammerhead shark can be modeled by that. Where T is the age in years. How old is the shark that is 175 centimeters long? So it looks like we're just plugging 175 in for L and solving for T. So subtract 266. Number's that?
Negative 91.
91? That's not nice. And then divide by negative 219. Okay, so I have and then you could write this as a log, or you can undo an exponential with e as the base of the number by just taking the natural log with log base e on both sides. We get negative 0.05. Oh, there probably is a t there at some point. T equals the natural log of 91 2/19. Divide by this number. And we get the years. (17.5642). Any questions? Is that good? Wait, who asked? Yeah, was that good? Anything else? What did I assign? Through what? 27, not 19. No problem. 23, no problem. 25. What was that? Good. 27. This is 10, right? That's all you had to do. You didn't have to do 29, which looks pretty easy. So we're good? No questions? All right. I think we're done with transcendental functions. We're just going to have regular functions now. I think, as we look at 7.3, inverse variation, nah. Graphing rational functions, nah. Multiplying and dividing rational functions, rational expressions, that's probably pretty important. So let's make sure you do that. Here's how this works. Multiplying fractions. You just multiply the tops to get the top. And the bottoms to get the bottom. Then reduce it if you can. Or dividing fractions. Remember how to do that? That's 4 elevenths times 3 halves. And you can cross cancel before you multiply. Bless you. 2 goes into 2 once, 2 goes in 4 twice. 6 elevenths. How about something like 6? Negative 3 over 2x plus 1 times x plus 1 over x. Bless you. You good? You make it? Bless you. Okay, what about that? What is that? Can you cancel anything? That feels like you should be able to. Right, look at this x up here and this x down there, like just waiting to be canceled. Can you do it? No. You cannot cancel things that are being added or subtracted. Really, this is negative 3 times x plus 1 over x is 2x plus 1. Oh, look at the x plus 1s. Can't you cancel those? No, this factor does not look like that factor. This has a 2. Cannot cancel anything unless it's exactly the same. You guys might be good at this stuff. Simplify rational expressions, multiply rational expressions, divide rational expressions. What's stuff? Like, do you know what 72 divided by 12 is?
6.
Can you do 72 divided by, and do too easy. 16?
6 divided by 16 is not 3, 4. No.
Like 4.5.
Only 4.5. Like half of 9? Yeah, it is 4.5. That's good. How do you guys do that? Like 72. What did I say divided by 16? Like that's that. And what can you cancel? You can cancel these 3 2s. And you're left with 9, yeah, it's 4.5. Right? That's the way division works. Okay. How do you reduce this? We're going to try it, everybody. Get an answer. Point to it. Don't cancel anything between added or subtracted. Only cancel factors. So what do you think you have to do to it before you can reduce it? And you can only cancel factors. What do you have to do to the numerator before you can do anything? Factor it. What about the denominator before you do anything? Factor it. That's how to do these problems. You cannot cancel the x squares because they look so tempting. You have to resist the temptations that the young teenager has. Look at that. Just hoping to cancel out the squares on those x's. Is that the temptation that you hold? You must train yourself to resist. Time and time again, you'll be tested as a teenager going through the world. Train your mind and body to resist certain temptations. Did you guys get answers?
Yeah.
Yes.
All right, let's see who this rando did.
Oh, yeah.
It's going to be Marcus, and he's going to be so glad he wasn't here.
April Fools. It's.
Oh, Maureen. Let's see. Oh, Andrew. And Joseph. What do I do, Maureen? Maybe you can lead these young teenagers out of the darkness. What's that? What do you get when you factor this numerator?
Minus 6, max plus 2.
X plus 2. Good. What about the denominator?
X minus 2,
X minus 2,
x plus 2.
x plus 2. Can I do anything else? There are certain times in life we just have to go with the temptation. Is there anything you want to cancel? You can cancel something.
X plus 2.
Yeah, those two cancel. I didn't check to see if you factored it. They cancel. The whole factors that are identical, those two cancel. And the answer is x minus 6 over x minus 2. Can you cancel these x's? Then you want to. Can you just do it? You cannot just do it. Let's resist the temptation. Any questions? Andrew, let's do number 1 here.
You can cancel the x plus 1, so it's 2 over x plus 3.
Exactly right. Joey, number 2, what do I do?
Leave factor x squared minus 16 equal, maybe x plus 4x minus 1. And then you cancel out the x plus 4 and look at the 1 on top.
Ooh, outstanding. Forget the 1. Bless you. Exactly right. You cannot cancel parts of sums, but you can cancel whole factors, as long as they're the same. Why don't you guys do these 2? Is there hope for your generation? Find out. Marcus. Why? And next. Wyatt, what do I do? Can I reduce the 4 and the 2? What can I do?
I don't know how to do them.
Good answer. Remember, no means no. We cannot reduce it. Do not reduce it. X. Can I cancel these x squares? You're correct. What do I do?
Back to the top and
Excellent. How's the numerator factor?
x plus 1x minus 3.
Good. X plus 1, x minus 3. How about the denominator?
X plus and x minus
Good.
positive 2 negative
Nice job. Can I cancel anything?
3. X minus 3.
Yes. And the answer, x plus 1 for x plus 2. Looks like the answer is 1/2, right? No, it is not 1/2. That's good. Passing all the tests. Any questions? This is where it gets terrible. You kind of get trained to just cancel anything willy-nilly. If nothing is being added or subtracted, just cancel at will. Anything you can cancel, you shall cancel. What do you see that I can cancel?
Can you simplify that?
Yeah. Good. Now what?
And then 11, so,
It's cross cancel. You can do that.
oh, okay. Oh, then you can cross cancel the 4s,
4's cancel.
and then a y.
1y cancels.
And then now you can make that.
Good. What do you get?
7x to the 6th
Perfect.
y.
Oh yeah, there's a y too. Nice job. Any questions? This is the problem. I train you and teach you only to cancel factors. And then the next problem is no factors at all. It's just only factors. So you don't have to distinguish with sums and factors and only cancel the whole factors. And then we do this one, and then the next problem, you have to factor and cancel. And then students just lose their minds. Just have to hold off. Take a second. Breathe deeply. Say no to certain temptations. Why don't you try to do this? We'll have Ty, Alex, Cerise, Ella do this next one. Is there an earthquake? Alex quake. Trying to set it up so the right person comes up. All right, let's see who's going to do it. Randomly choose a student. Evelyn. It's close about it. All right, what can I do?
Can you just shoot the negative?
You could. I don't know why you do that, because you want to factor everything, but. Can you take anything out?
The 3x.
Good, we can take a 3x out. I'm going to leave the negative out, factor 3x, what's left in then?
X minus 1.
X minus 1. Good. Denominator, what can we factor?
X. Plus 1 minus 5. Oh, yeah, plus 5 minus 1.
Good. This numerator?
X. Plus 20 minus 1. Or plus 4. Plus 5 minus 4.
Good job. Very good job. Now what?
On
this one, this
Right.
negative one that remains.
And then cross cancel x plus 5.
X plus 5. So what's the answer?
Negative 1 x minus 4.
Nice job. That was not an easy one. So what did you do? You didn't do that when I gave you time to do it, did you? What did you do when I gave you time to do it?
And I was confused, so I was just gonna
It's really unbelievable how you recovered from that. You did it perfectly. I knew when you told me to distribute, I'm like, maybe she made a mistake. And then you were factoring, it was like, take me a little longer. That was very good, really good work. Who is Ty? Who's gonna be next? Ty. I'll just leave it there. Ty, what do I do?
On the factor the bottom, then x plus 3, x minus 3.
Nice.
Then you factor the top over there, x. X plus 3 in both.
Good.
And then you can cross, like, you cancel one of the 3x's with the 3x in the bottom.
You're saying 3x.
Oh, sorry, 3 plus, x plus 3. You can cancel that with x plus 3.
Okay. Can I cancel anything else?
I don't think so, no.
So what's left on the top?
X plus 2, and then x plus 3,
What's left on the bottom?
x minus 3.
Can we give you another chance? Is there anything we can cancel?
I don't think so.
Is that a yes or no?
No,
Say no.
no.
Correct. No. Good job. That was good. Any questions? Why don't you try these? Like, these aren't bad. No addition, subtraction, cancel anything. These are cruel. There's like alone factors, there's some things you can factor something out with, there's other things you have to factor. And then you have to know what to cancel. Impossible. Ooh, x cubed minus 1. Do you remember how that factors? Into a binomial and a trinomial. All right, try them. If you haven't been called on yet, you better be smart. There's only 2 people, 3 people. Max, I call on you, right?
Yep.
Just 2 people. Alex. Cerise. That's gonna be fun. See you next. Huh. All right, let's go. I'm running out of time. Oh, Cerise. That means Alex is the most difficult one all day. There he is. All right. What do I do?
I think you reduce the second one, the 6x.
This?
Yeah,
want me to reduce these two? Or these two?
Like both of them?
Alright, so I'll cancel this one y and one of these y's. Right? Same thing here, this one y, one of these y's. Good. Now what? How about x's?
The cross ones, the 2x and the 8x, or the x will cancel.
You just want to cancel that x and that x. Great. Should we rewrite? It's getting a little ugly. So 3x to the fifth y over 8 and 2y over x to the third. You see anything else you can cancel? You can cancel anything. There's no addition, no subtraction. You can cross cancel. Like the 2 and the 8, those reduce.
Oh, I agree. Oh.
And the x to the fifth and x to the third, those reduce. Because when you multiply, you just multiply the top, so you get the top, multiply the bottom, so you get the bottom. So it's like that one division bar just separates the numerators from the denominators. So what can I cancel?
So you're saying that I could cancel or I could reduce the 2 and the 8 to be 1 over 4? Or 1 and 4?
Yeah. And the x's also.
X squared?
Yeah, so these 3 x's cancel 3 of these 5 x's. And just 2. So the top, what do I have? 3 x squared y squared. And the bottom, 4. That's it. Alex, what do I do with this top left? What's that? How does that factor?
2x x minus 5
Not this one.
x minus 5x plus 1.
Good. How about? What can we cancel?
X minus 5 and 2x.
2x I can cancel. I get rid of 2x here, I get rid of 2x here, and left with just an x there. Anything else? Good job. X plus 3 on the top, x times x plus 5 on the bottom. So this factors into x minus 1, x plus x squared plus x plus 1. This doesn't factor. X squared plus x plus 1 cancels that one. You're left with x plus 5 over x minus 1. All right, good luck on that homework. Be awesome. Good job.